for 6 months and trying to get caught up on what's actually going on within my own organization. So it'll be good to see what John's up to here.
Great. Yeah, welcome back. And thanks, everybody, for joining us. So let's go ahead and get started into today's agenda. And what we're going to do here, I guess I should stop playing with my webcam and get into All right, so what we're going to do here is do a little introduction on spatial decision support systems, and then we'll talk about this particular application of it. And it's a hierarchical multi-criteria framework that also has a conservation area prioritization algorithm. And but the big thing here is a lot of this is customizable in Model Builder. Some people are already taking it into script. Mark and Randall have done that. And then we'll talk about some new directions and next steps. One of the new directions, of course, is this collaborative network and sharing models across organizations and moving forward in that arena. And we'll have a little discussion. Now, we won't have time for a full discussion. We do have an online community where we'll be able to follow up discussions. And we also have a bi-weekly webinar where you all are invited to join, in which we look at individual topics. So, just so we're all on the same page, just a little bit of a conceptual diagram here on the spatial decision support system. It's not the decision-making system, and over here in the lower left corner, key part of it is not only does it have data and science going into the computer system, but also human values and opinions go into it as well, but it's in a systematic and transparent way, so you can see what the human values are. From that, you get maps, tables, and all sorts of outputs that are used as a reference by decision makers, be it 3 people without any eyes and mouths sitting around a table making decisions, or be it a whole group of stakeholders or even a whole online community. They're going to combine the decision support reference with their own innate knowledge, experience, observation, and hopefully making a wise decision about land use or management. And that's kind of the focus so far on the collaborative. So some example prioritization topics. This is from a slide that I presented to the Wilderness Society in September. But some potential prioritization topics that were relevant to that would be look at new wilderness candidates. Where are the new top prioritization areas for becoming new wilderness? Why? Look at different forest restoration prioritization areas. Looking at solar array and/or wind farm siting. The whole renewable energy thing is really big, especially on BLM land, but it could be on all sorts of public land. Forest management plan. And again, this is a spatial decision support system. And these are examples. Like in Islands Trust, it's a whole different issue. Mark just finished an example there where looking at new areas prioritized for purchase or acquisition through a conservation easement. So some of the goals for this decision support system, forgive the old acronym there, that stood for, well, we won't even go into that. Well, yeah, engaged conservation planning and management, that was the old acronym. But the idea behind it is that we want it to be also broadly participatory in use for a variety of reasons, which I've presented at a different presentation, but we won't go into it now. But allowing people to provide data contribution, parameterization, and also validation. So really opening things up to the citizen science angle. And also, it would be nice to have a decision support system that's broadly participatory in development itself, with grabbing onto the whole Web 2.0 thing. So I alluded to that earlier, and we'll get back to that. Now, as far as some of the scientific goals, pushing decision support systems forward, because we know that there's hundreds of them out there. Some of the ones that we were really interested in is first goal is looking at this idea of looking at the best conservation network and having a good conservation network and a vision for that, but also being able to use your decision support system for real small, fine-scale decisions as far as like individual properties or sub-watersheds, and really going down into those and getting really good ideas of the relative conservation value of those areas. So the goal for this decision support system, the third goal is that conservation assessment should not only identify a network of sites to conserve, but also the conservation value and attributes of every site in a study area. Secondly, we live in an uncertain and dynamic world where these conservation plans, they get outdated quickly. We know this slide right here. And so with greenhouse gases rising, development pushing all sorts of climate change variables, and the political landscape is changing so fast, your vision of your ideal conservation network is going to change quickly if you incorporate all those changing variables. So another goal of this decision support system is to move away from once-off conservation assessment toward living decision support system. And then the fifth and final goal that I want to highlight here is okay, there we go. PowerPoint just had a hard time with that. Okay, well, actually, even before going into that fifth goal, here's an example schematic of that, which is also on the community website, so I won't go into it too much. But you can see here's the flow of making the decision support system, having that support decision-making, making that go into helping implementation, actual on-the-ground changes in ownership and management, but then all the while having adaptive management and monitoring of that, feeding back into your system, both at the site report level, but also into your GIS database, so that you can continue to have real-time site evaluation and real-time decision-making based on what's on the landscape. So you can imagine not only is adaptive management and monitoring feeding into this, but there should be another arrow coming to this direction, which is all the other new data arriving to this changing world that we live in. And so the fifth and final goal is accounting for the diversity we have in conservation strategy. Here's an example of cows in a field just kind of not doing too many good things for this little riparian area. But if you go ahead and do a restoration initiative, here's the same exact little drainage that's been restored. And yeah, this has definitely been an improvement for conservation. But in a lot of the traditional conservation planning metrics, this area didn't really count as being conserved or improved compared to the previous area. So there's this shades of gray that weren't incorporated into traditional conservation planning metrics. And so this decision support system is one of the goals of that was to incorporate those shades of gray. So incorporate not only shades of gray, but also the different types of conservation. So including private stewardship and different types of working landscape options, and recognizing that those are benefits of biodiversity, incorporating that in our accounting system. So in looking at software to facilitate this, when we were just first starting looking at how to incorporate all these different things, and I was tasked to build a decision support system there in South Africa. One possibility was to piece together some existing software tools, such as MarkSand with stones, which allows you to look at those different types of conservation strategy. NatureServe Vista is really good at looking at the conservation value of individual areas and comparing different sites. There's different algorithms, software out there such as Corridor Designer, which look at making connectivity between your sites and building your network, but linking them all together could be problematic, and especially we wanted to look at this for the long term, like looking at decision support system that we could be using 10, 15, 20 years from now and on. So fortunately, we have the luxury of building it from scratch and building on a whole bunch of other theory that had been previously developed that Jason alluded to, and I'll mention in an upcoming slide. And so the development was based on, it's in ArcToolbox, so you need an ArcGIS 9 license to be able to use this, but that's becoming pretty ubiquitous. You need spatial analysts, and it's done doing using Model Builder, which is part of ArcGIS, and also there's some Python scripting where Model Builder falls short. The idea is that it's integrated, shareable, customizable system. It's free as long as you have the software, and in that way it's open access, and it's built on what can be termed as a return on investment framework. And I won't go into Model Builder right now because I think most of you are somewhat familiar with it, if not very familiar with it. But if you aren't, in a nutshell, it's a program within ArcGIS that allows you to basically to program your GIS commands together and link them together. So, but you don't need to know command line coding to do it. It's based on a drag and drop interface where you use arrows to connect commands together, and you can right click and get options to do iterations and things like that. And on the online community that I mentioned, we have links to several different types of tutorials and demos. So a little bit, really brief history on the return on investment framework, and in some respects it can be started, you can look at it as return on investment for conservation. There was a group of people, the NC's working group, which is a group of high-level scientists that got together based on this California Legacy project, which was funded by the government of California. It led to a couple different papers. One of them published in Ecology. Wait, Society and Ecology. Well, they changed the name. Jason, what was the name of that journal again?
Sorry, I was muted. Ecology and Society.
That's right. It was Ecology and Society. And so that was really exciting. And so, as Jason mentioned, I was there at UCSB while that was happening. He was there. Frank Davis was Jason's advisor. He was one of my committee members. And it was just really exciting to see the theory and the ideas going into that. I recognize that having a lot of potential. Meanwhile, over in Australia, Hugh Possingham and his team were also looking at the same type of framework, and they developed a similar paper. And my dissertation in 2007 alluded to it. I used the framework in a case study in the Santa Barbara region, developing the Regional Conservation Guide. And then I went over to South Africa, and we developed it further. And so, in a nutshell, the return on investment framework is getting the best bang for your buck. It's basically a benefit and cost framework. In this application, we use the multi-criteria hierarchy to do it, and this idea of continuous benefit functions, which I'll get into in a minute, which is it's continuous accounting of habitat representation or any other representation for that matter, rather than this discrete accounting that we're used to. It's when in Marxant, for instance, you set a target of, say, 25% for a particular habitat, and you've either met that target or you haven't. And the continuous benefit functions much more nuanced than that. And then as a result, it's a lot easier to account for partial benefits of biodiversity. This framework also, in this application, puts connectivity and contiguity algorithms into it, and it does the solution sets and site assessment. So in a nutshell, it does meet